So looking at this, I'm going to start with number 11. We're just going to go through the definitions first. So I'm going to start with A. So what is the middle point of a circle? What is that called? The center. So number 13 is A. What is the line segment whose endpoints lie on a circle? So it's a segment that doesn't go through the circle. It stops at the circle. Is it a chord, a secant, a tangent? Is it a chord or a secant? It's a chord. A chord stops on the circle. Okay? A type of chord that goes through the center of a circle. What type of chord goes through the center of a circle? It's either radius or diameter. Which one is it? Diameter. So a line that passes through the circle twice. Is that a secant line or a tangent line? Secant. Tangent only touches it once.
That's more. You have to have extra pencil.
Does anybody have an extra pencil for the needle point?
I give y'all $1.
Okay, so what is an arc that extends exactly 180? Is that a minor arc, a major arc, or a semicircle? Semicircle. Okay, a segment that extends from the center point of the circle to the perimeter. So from the center to the side, a radius. Okay, the point where the tangent line touches is called the point of tangency. So number 17 is G. Okay, an angle whose vertex is on the circle. So it's either inscribed or central. Because on the circle, that means it looks like this. Is that central or inscribed? Inscribed. So 22 is H. Okay, an arc that is more than 180. Is that a minor or a major? Major. Arc. Okay, an arc that's less than 180 is a minor arc. A line that intersects the circle at one point is tangent. And an angle whose vertex is at the center is a central angle. So that central angle looks like that. So looking at this circle, we start with A. What is RP? R to P. It's an arc because it's on the circle. So is that a minor arc, major arc, or a semicircle? Minor arc. So number 8 would be A. Okay. Then B is SN. What would that be? The center. The center is just a point. That's a line.
Oh.
The line that goes all the way across through the center is a diameter. So B is number 4. Okay. C, we have arc K, N, R. So start at K, go to N, then to R. K, N, to R. Is that a major arc, minor arc, or a semicircle? Major, because it's bigger than 180. So number 9 is C. Now, N to O. How many times does that touch the circle? Once. So is that tangent or secant? Tangent. So number 5 is D. What's point Q? The center. E goes on number 3. Okay, QN. What's that? It's a radius, chord, secant, point of tangency, or a semicircle. The radius. So F goes on number 1. Okay. Point N. What's that? The chord, secant, point of tangency, or semicircle. The point of tangency. Number 7 is G. Okay, arc SPN, semicircle. Halfway, and the endpoints are on a diameter. What would that equal? How many degrees? 180. H goes on number 10. Okay, what's LM? A chord or a secant? Is that a chord or a secant?
Let's see.
Chord. Because it doesn't go through the circle. If it extended out like that, then it would be a secant. But since it stops on the circle, it's just a chord. And then K to R, see how it extends out? That will be a secant. So make sure you got those. Okay. So now on this part, we are going to name parts. Just looking at, we're going to look for a radius. So for a radius, there's technically 3 different answers you can have on this one. So if you do it ahead of me and you get a different answer than me, that doesn't mean you're wrong. It just means you might have put a different one. So looking at number 23, we want to find a radius. So that means it's starting at A and then going to the side. What's one of those radii? A to D.
Could you do DA?
You could do DA, you could do AG or GA, and you could do AF or FA. Because all 3 of these are radii. Okay? So now we want a chord. So there's only one chord in here. Would this be a chord?
Yeah.
No. What would that be? Secant. So we know BD is a secant. So I'm just going to go ahead and go down to secant on number 28, and I'm going to put BD for that one.
Chord is AF
AF is a radius.
or CE.
CE is a chord. This right here is a chord. Because it touches the circle on both endpoints, but it's not through the center, and it doesn't extend out. So CE would be a chord. What did you say, Owen? That is technically a chord, but it's a diameter. So GD, since it goes through the center like that, if it goes through A, that is the special type of chord, which is the diameter. So you want to just put that on diameter instead of just a chord, but technically it's a chord, so it would be right. So GD is a diameter, so I'm going to go ahead and write that. Okay, what's the center?
A.
A. If you just write A, that's fine. If you want to write point A, that's cool too. You don't have to write the point part. Okay? Now we need a tangent, which means that it only touches the circle one time. That's going to be one that's outside, looks like it's outside. So this is your tangent. You just say GH or HG. I put little arrows over it because its lines have arrows at the end. But again, I'm not going to count off if you put the wrong thing, as long as you put a line over it. Okay? So now, number 29, what is the point of tangency? So point of tangency has to be on the tangent line. Which one is the point of tangency, H or G? G. G will be your point of tangency. Okay. So now we want a minor arc. Again, there's multiple minor arcs you can have. So you can have GB. You can have GBC. You can have DC. You can have DB, DE, DF, GF, GE. Any of those are minor arcs. Somebody tell me one minor arc, and we'll write that.
DF.
DF. Put a little rainbow over it. Remember, when you're doing a minor arc, you only use 2 letters. Major and semicircle, you use 3 letters. Okay? Somebody pick a letter on there, not H or A. G.
B.
B. And then I heard D. So we're going to go from B to D. And then I need more to make it a major arc. E. So E, we don't know for sure if that would be major, so I'm just going to extend it on around to F. So B, D, F would be a major arc. Then we have a semicircle. Semicircle has to end on the endpoints of a diameter, so I know I'm going to have G and D, but I've got to find a middle letter. It can be any of these letters. Just depends on which arc you're looking at. So do you want it to be B, C, F, or E? E. So that would be this arc right here, G, E, D. That would be a semicircle. Okay. So now, looking for a central angle. There are 2 central angles that I see right there that are pretty easy to see. But remember, it starts at the center, or the vertex is at the center, so this right here could be a central angle, right? So I'm going to say angle GAF. Remember, the vertex has to be in the middle, so that's why A is in the middle. You could have said DAF. You could have done GAD. Because that's technically a central angle, but I would prefer one of these because those are the more prominent central angles. Okay, and then we need an inscribed angle. So, is there an angle coming off of this? Is there another angle coming off that line? No. Is there another angle coming off this line? No. What about this one? That creates an angle, right? Is that an inscribed angle? Yes. So that right there is my only inscribed angle on this triangle. So angle GBD or GDB or BDG, either way. G, B, not B, G, D, B. G, D, B. Or B, D, G. So there's your review of naming parts of the circle and looking at those things. Now we're going to go to the central and inscribed angles that we went over. So, flip over to page 3. We're going to talk about central angles first. So, central angles are always have a vertex at the center. And on your paper I wrote this, but with that you know that the angle equals the arc. The angle always equals the arc. And remember, if you have a diameter, those equal 180. So this right here, that's a diameter. So how can I find this one? Diameter, that half equals what? 180. So if I want to find KJ, I'm going to do 180 minus 180 minus 140. And that's going to give you what? 40. So if that angle's 40, or that arc's 40, this angle's 40, that angle's 40, this angle's 40. So what would GH equal? 40. Because of vertical angles and vertical arcs. Now how can I find IJ? You could do 360 minus everything, or what do you know about this?
What, 180 minus 45?
You could do 180 minus 40 minus 45, or 360 minus everything else. So what does IJ equal? What's 180 minus 40 minus 45? 180 minus 85.
What, 105? 5.
It's 95.
Okay, so it wanted something specific. So it wants to know what angle IFJ is. What's angle IFJ?
95.
95. Okay. So this has a 90-degree angle. This one's 90. This is 40. And then how could I find what HI is? Subtract what? 180 minus 90 and 40. So 180 minus 90 is 90, 90 minus 40 is 50. So if this angle's 50, this angle's 50. Then if we needed to find this, we could do 180 minus 50. I know that both of those are 50 because they're vertical. But 180 minus 50 is 130. So this angle would be 130. So it wants to know arc GI, this entire arc right here. So
That's 90.
it is 90. 50 plus 40 is 90. There's 90 left. There's 21 of them.
Is that a lot? Are they like out in Thornton or is it just absent?
There's 3 of them.
Is Katie
So
one?
they should be back
Class.
tomorrow.
Who come back?
Katie should be back, Aaliyah, Jasmine. Jasmine, don't y'all come back tomorrow? Can't wait.
She probably sleep.
Felt that. with y'all.
I was up at 7, but that's all my program, and then I went back.
Okay, so looking at this, we're gonna solve for x. So we need to know what this arc equals before we can solve anything. So we know all of the other 4 arcs, right? What are all 5 arcs always add to equal? 180. Nope. 360. Half the circle is 180, but the whole circle is 360. So all of the circles should equal 360. So I'm going to do 360 and subtract all of those other arcs. What's that? I heard somebody say, oh, 50. 50. So this arc equals 50 degrees. So now if I want to solve for x, what am I going to do?
Set it equal.
Set it equal. So x plus 59 equals 50. You are going to get a negative. So subtract 59. And what is 50 minus 59? Negative 9. $360 minus all 3 arcs, or all 4 arcs. And what's 360 minus 265? Anybody? 95. Okay, so then we'll set 10x plus 15 equal to 95. Subtract 15 from both sides. We'll have 10x equals 80 divided by 10. X does equal 8. Okay. Anybody got any questions? Same thing on number 5. We're gonna do 360 minus all the arcs that we know, so 360 minus the sum. Not all of them. These just so happen to be all of that. So 360 minus 330. When you add them all up, it's 360 minus 330. 30. So x plus 35 equals 30. Is how we'll solve for x. So subtract 35. And what's 30 minus 35?
-5.
-5.
They come back with that.
We'll come back.
I got a question. How many days of school do we
Right,
Weeks.
15.
have? How many weeks?
There's 3 weeks, 15 days.
3 weeks.
Yes, we have 15 days.
Or something like 2.5 weeks.
You're not gonna get
2.5.
No, it's 3 weeks, but we only go to school 5 days a week, so 15 days of school.
Oh.
Yes, and then those last 2 days are technically half days.
Wait, don't you like not have to go the whole
So do we have
time?
to, so do we have to come to school those days?
Yes, because you have to take time.
Well, can't you get out earlier? You know,
Yeah,
like,
it's
like-
our finals.
Before we get into solve for x, we have to know what that arc right there is. We have to know that arc. So, what we are going to do is we're going to find a way to find what that equals. So, what do we know about this line right here? That is a what?
Minor arc.
The blue part is a minor arc, yes. So the diameter, that's right, the diameter is that red line. What do I know about the arcs on that side, on one side of it? It equals
180.
180. So 180 minus 33 should give me what the blue arc should equal, right? So 180 minus 133. Gives you what? 47. So this arc's 47. Now that we know that arc, we can now solve for x.
We should do 7x minus 2. So then why can't we just do those in the rest of them?
Because you have to find the arc measure first. So 7x minus 2 equals 47. Add 2. You get 7x equals 49. And what's 49 divided by 7?
7.
X equals 7. Okay, on number 7, notice we have 2 diameters. We have a diameter right here and a diameter right here. So what do we know about these 2 angles? They are vertical, right? Those 2 angles are vertical.
So they're
If 2 angles are vertical, that means they are the same.
So it's
So this arc is 40.
So is it all together? Come on now. Oh, you sleep.
Okay, so I'm gonna have negative 3x plus 7 equals what? Well, negative 3x plus 7 equals 40. So subtract 7. Negative 3x equals 33.
It's gonna be, negative.
So divide by -3, and x will equal -11. Okay, number 8, this is a diameter. So what should both of these arcs add to equal? 180. So we're going to add those two parts up, set them equal to 180. So I'm going to have x plus 137, x plus 53. I'm going to add those and set them equal to 180. Okay, so x plus x is 2x plus 137 plus 53. 190. So now I have 2x plus 190 equals 180. What do I need to do with the 190? Subtract it on both sides. So I have 2x equals -10. And what's -10 divided by 2? -5. So x equals -5. So an inscribed angle has a vertex on the circle instead of at the center. So we use our formulas, which is 2 times angle equals the arc, or the angle equals arc divided by 2. So if we're looking for an angle, we'll do arc divided by 2. If we're looking for an arc, we'll do 2 times angle. So on number 1, we're given an arc and we're trying to find an angle. Am I going to do 2 times angle or arc divided by 2? Technically, you could do either, right? Yes? Which one do you want to do? 2 times angle or arc divided by 2?
Arc divided by 2.
Okay, so we'll do arc divided by 2, so 80 divided by 2 gives you what? 40. So that angle is 40 degrees. That's it?
You might actually pass the test.
Okay, so this time we're looking for an arc. Do you want to do, and we're given an angle. Do you want to do 2 times angle equals arc, or arc divided by 2 equals angle?
So we could do either one.
Either one. Either one will give you the answer. In my opinion, 2 times angle will probably be the easiest.
2 times 70.
But they're the same formula, just if you divide both sides by 2 on angle, 2 times angle equals arc, you'll have the red formula. But since we're given an angle, I'm going to do 2 times angle. So 2 times 77 is what? 154.
Stop doing it.
Okay. So now this one, number 11, is a little bit different. You've got to find the arc measure first, then you can find the angle. So if I need to find this arc first, I'm going to do 360 minus the other 2 arcs. So 360 minus 78 minus 118. And what does that give you?
164.
164. And then, since that arc's 164, we can do arc divided by 2 or 2 times angle equals arc, doesn't matter. I'm gonna write both of them, you can pick which one you like best. So you could always use 2 times angle equals arc, 2 times x, because we don't know what our angle is, equals our arc, 164. And then if we need to solve for x, just divide by 2. And it ends up being arc divided by 2, just like the other formula. So what's 164 divided by 2? What's 164 divided by 2?
82.
82. So our angle is 82 degrees. Okay. Now on number 12, in order to find the arc that you need to find, arc MK, you first have to find arc KL. So basically we're working backwards from what we just did. So, first we need to find arc KL. So I'm given angle 39, 2 times angle equals arc, so 2 times 39 gives you what? 78. So this arc is 78 degrees. So now to find arc MK, I'm going to do what? 360 minus what? Am I going to do 360 minus 39? Not 39, we're going to do 78 and what? 158. Their arc on number 13. So if I want to find out what that angle equals, I've got to find what this angle equals first. I'm going to do arc divided by 2, right? Yes. So 94 divided by 2 gives me what? 47. So since that angle equals 47, I'm going to have 3x plus 5 equals 47. You could have also done it a different way. You could have just plugged it straight into the formula. 2 times 3x plus 5 equals 94. There's just a little bit more algebra with that. Okay, so 3x plus 5 equals 47. Subtract that 5. So I have 3x equals 42. And what is 42 divided by 3? 14.
14?
42 divided by
I
2
hit
is
2 by
21.
that.
So x would be 14. Okay, so same thing on number 14. First, we need to find the angle, or inscribe the angle. So I'm going to do 190 divided by 2. What's 190 divided by 2? 95. So then I'm going to set 6x plus 23 equal to 95. Okay. So what do I need to do with the 23? Subtract it from both sides. So I have 6x equals 72. And then divide both sides by 6. What does x equal? 12. Okay. So 2 times 30 will give you your arc, which is 60. And then we're going to set 13x minus 5 equal to 60. So add 5 to both sides. Got 13x equals 65. Divide both sides by 13. And what do you get? X equals 5. First, we had to find our arc KL. So 180 minus 184 gave me 76. 76 divided by 2 gives me my angle 38. And it's at 3x plus 11 equals to 38. So now what am I going to do with that 11? Subtract 11. And we'll have 3x equals 27. What's 27 divided by 3? 9. Okay, any questions on 15 or 16? Number 17. We need to know the measure of arc EF. So what am I going to do with that 62? Multiply it by 2 or divide it by 2? Multiply it. So what's 2 times 62? 24. So this arc is 124 degrees. So I'm going to set 11x plus 14 equal to 124. So subtract 14. Have 11x equals 110. And what's 110 divided by 11? 10. So x equals 10. Okay. Number 18, first you've got to find arc in M. Got to find this arc first. So I'm going to do 360 minus what? and 69. 113 and 69. Subtract those from 360. What does that give you? 178. So this blue arc is 178. And then divide that by 2. And that'll give you what 11x plus 1 should equal, which is 89. So I'm going to set 11x plus 1 equal to 89. So subtract 1 from both sides. Have 11x equals 88. 5 by 11, what does x equal? X equals 8.